Morning class. So we're going to learn application of integration today. All right, this color is not good. Let's take this. Yeah, application of integrals. Right. So before we start the topic, let's first understand where it's really applied. Even in our syllabus, it's not going to show us where it is really applied at. Okay, so so all of you have this question, right, after doing the heavy chapter of on integration previously, which is very important for scoring marks in your main exams as well. So let's first understand where it can be applied. It can be applied in a lot of real world scenarios. For example, share prices. Share prices are derived using integration. You might be wondering, what am I talking about? Share prices are derived from the value of assets, right? Not really. Share prices are a function of people's prediction what the share price can be, and integration as a tool can be used to predict what can happen. It's basically a function of summation on continuous time. That is the difference. I told you in the chapter for integration that when you take 1 plus 2 plus 3, we can write summation and then put I and then put 1 to 3, right? But if it's 1 plus 1.0000 dot like 1 and then on the real number line, so like all numbers from 1 to 3, if I have to add, then I will do integration, say x dx from 1 to 3. So this is called on the continuous time basis, right? So what we are going to learn here is, I'm telling you where it is applied so that you actually have interest in learning the chapter as such. Share prices, this is going to be very interesting. It can help you calculate probability of death of an individual, right? So you'll be wondering, how is this possible? So how is a person going to, what are the factors of a person's death? Age, right? Then the physical condition that he is in, then his smoker status, does he smoke alcohol, all those things which take into consideration becomes a function, and then you apply integration, and then you find out the probability of this person dying or not. So this is where, and there are lots and lots of other real world application that is so it's a wide field. Okay, now coming back to what the CBSE wants us to learn, right? CBSE wants us to learn a few basic things that integration is required to, you know, that we need to do. So I'm going to take you down to what is needed in that. Just a second, let me scroll. Here is our book. I attached it on OneNote previously. So I'm going to go directly into a simple question, okay, which is example 3 in our book. Just to show how I inserted the book, I went to insert, right? I went into file. Uh, this PDF I downloaded from the NCERT website, and then this is the file, and then if I click and open, it will come into the OneNote. So now let's solve this question, what this question really wants us to do, right? It wants us to calculate the area bounded by, okay, so to make it a little more visual or something, so this is y is equal to 4, right? And this other curve is x square y is equal to x square. Now they want us to find this area, right? But now what we're going to do is we're going to take this part alone. That's what they're saying here. Okay, here they're calling the area B, O, N and B, bond, right? So what we want is we want to find the total area, so which is 2 times the area of this place. Let's also name it B, O, N, right? And we want the area of this portion. What we're going to do is we're going to take the integration from this part. So just reimagine this graph only for this much. We need this area. So how do we do it? What we do is first we know that the function is given as y is equal to x square, which is not going to work because the limits that we have, that is 0 and say 4, okay, the limits are on the y-axis. Okay, so we need a function that represents x is equal to something. So x is equal to root y. Okay, we need this. Now using this, what we are going to do, we're going to take it and solve the integration. Oh, once again. Here. So we're going to take 2 times integration 0 to 4 root y dy, right? And this will be nothing but 2 into 2 by 3 into y to the power 3 by 2 from 4 to 0. Okay, you take 4 by 3 here, and then you put 4 power 3 by 2 minus 0 power 3 by 2, and then you're gonna, let me scroll, yeah, oh sorry, 4 by 3 into square root of 4 then time power of 3. So we get 8 minus 0 over here, which is 8 for the 32 by 3. And if you look at the answer, it's the same thing. It's asking why. We just found out why. So that's it for the introduction. Let's meet later after a few more classes.